This is a 2-day lesson on 1-3 for algebra. We're getting to know how to use the calculator a little bit more today. I can use the calculator, describe the graphs, and sort them into families. I can determine whether a relation is a function or not. So in the previous lesson, we determined which of the given graphs represented functions. It was either yes or no, depending on the vertical line test. So what we're looking at today is more the characteristics of the graphs. First of all, an increasing function. An increasing function, as you read the graph going from left to right, an increasing function goes up as we go from left to right. A decreasing function goes down as we go from left to right. Just like we read a sentence, that's how we look at a graph and determine whether it's increasing or decreasing. A constant function just goes side to side and does not go up and does not go down. So function notation, y is a function of x. How we write that is we write f of x. They say of, but it's f parentheses with an x inside of it. So an example would be a piggy bank has $5 in it. Each week, $2 is deposited, so it's added to the account. So that's the same thing as saying f of x equals 2x plus 5. That is function notation. Instead of saying y equals 2x plus 5, we would have f of x equals 2x plus 5. Now, you're going to see along the different chapters, you're not always going to have x and you're not always going to have y. We might have money in terms of weeks. So the amount of money equals 2 times the number of weeks plus 5. Or in function notation, it would be m of w equals 2w plus 5. All 4 of these things essentially mean the same thing. It's just if you're writing it in y equals form or function notation. Here are the different graphs that we're going to be looking at. So when we take a look at these, analyze each of the graphs from left to right, and we're going to sort them into increasing, decreasing, a constant, or a combination of increase and then decreasing. So I think the easiest way to do this is to just go back to the graphs and talk about each one. All right, I will uncover the answers here. You can always refer back to these if you want to, but I'm going to go back to the graphs and look at the graphs individually. So we're looking for increasing, decreasing, a constant, or a combination. So when I take a look at these, this graph is going down, going down, going down. So A is, but it's also going straight across. So it's not just decreasing, it is a combination. So this would be a combo. Letter B, same thing. It's going up and then going down. So this is a combo. Letter C, this is going up, 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 and then it goes down, and then it goes up, up, up. So this is a combo as well. Letter D goes down and then up. So this is a combination as well. Letter E is not a function. All right, we have 2 dots right above each other. So that is not a function. Letter F goes up and then down. So this would be a combination. Letter G, as we go from left to right, all that it does is go up, 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 up. So this is increasing. It only goes up as we go from left to right. This one is going down, 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 down. Now, it looks like it goes straight across, but if we actually zoomed in, we'd see that it continues going down. We'll learn about those type of graphs later on in the year. This is just decreasing. Letter I goes up and then down. So this is a combination of increasing and decreasing. Letter J is not a function. We have 2 dots right above each other, so that fails the vertical line test, so that is not a function. Letter K, as we go from left to right, it is increasing only. Letter L, as we go from left to right, it is going down, 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 so that is decreasing only. Letter M goes down and then back up, so that is a combination of increasing and decreasing. Letter N is not a function. There are 2 dots right directly above each other, so that's not a function. Letter O, as we go from left to right, just like we read a sentence, we're going down, 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 so that is decreasing. Letter P, same thing. As we go from left to right, it's just going down, so that is decreasing. Letter Q is going up and then down, so that is a combination of increasing and decreasing. Letter R is not a function. There are two dots directly above each other, so that is not a function. Letter S, this is a combination of things because it goes straight across and then it goes up, 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 so that's a combination. Same thing with letter T. Letter T, we're going down and then back up, so that's a combination. Letter U just goes straight across, so that is a constant. And letter V goes down and then back up, so that is a combination. So you can pause the video if you want and look at those. I also have the answers right here, sort of sorted out. So number 2, so each function shown represents one graph in the increasing function, decreasing function, or constant. Each function, so we're going to enter these and see what they look like, see how to graph them. So now that we're going to learn how to graph them, I'm going to show you how to type them into the calculator. Now, on all of these, they say f of x equals. Well, on the calculator, f of x equals is just y equals. Your y equals button is in the top left-hand corner of the calculator. So when we go to graph this, we're going to graph this first one, f of x equals just x. Your x button is right here next to your green button. Your y equals button is in this top left corner. So we're going to go to y equals, clear out anything that's there, and we're going to hit x. The x button is the green button. You can go to graph, and this is what the graph looks like. It is just increasing. The second one, so go back to y equals, clear out what's there. We need parentheses. The parentheses are above the 8 and the 9. We have 1/2. Now you could type in 1/2 as 1 divided by 2, or you could type in 1/2 as 0.5, or you could type in alpha and then y equals. Notice that it comes up with this n divided by d. We could do that. If we select that, that becomes a fraction bar that we could just type 1, use your arrow pad to go down to the 2, and then use your right arrow pad to go off of it, and that becomes the fraction 1/2. To do an exponent, we have to use the little caret button, which is right above the divided by symbol, and then that's an x. And then we got to get off of that. See how it's right there next to the x? We have to get off of that. So tab over to the right, do -5. So when we go to graph this one, you should get a graph that looks like this. That is just decreasing. For the third one, let's go back to y equals. Let's clear out that equation. So 2 to the x power, 2 caret button x, and then hit graph. Now on ours, this says when x is an integer. This really means that this would be a discrete graph. So we can't do discrete graphs on the calculator itself, unfortunately. So you wouldn't have a smooth curve. You would really have dots all along here at each integer. So you'd have a dot, 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 because it would have to be a discrete graph. Go back to y equals, clear out that one. The next one is -2/3. Now again, there's a couple different ways that you could type in -2/3. You could just do -2 divided by 3 and then put your x. You could do it like that. That's one way to do it. You could use it as a decimal, -0.666666666, put in a ton of sixes, and then your x. Or the easiest way is to do alpha y equals. We want number 1, numerator over denominator, and then type in our -2. Our negative sign is at the bottom, -2. Use your arrow pad and go down to the 3. Tab over and put your x. So we get -2/3 x plus 5. When we go to graph that, it looks like this. It's a straight line that decreases. Go back to y equals. Our next one is -x plus 3. Negative sign, x plus 3. Hit graph. We get a straight line going down. Now again, this one says where x is an integer, so this would be a discrete graph. We really wouldn't have that continuous graph, that continuous line. We'd have dots at every integer, not a continuous smooth line. For the next one, go back to y equals, clear out what's there. We have parentheses, 1/2. So again, you could use 0.5. You could do 1 divided by 2. I like using the alpha and y equals button, n over d, which is that first one. So we have 1 over 2. You have to use the arrow pad to get down and then the arrow pad to get off. Close your parentheses. We have to the x power, so caret button x. And now hit graph. This is what your graph looks like. And then go back to y equals. We have f of x equals 2. So we're just going to type in the 2. There's no x in this one. What happens there is that you have a constant. So you have a straight line going across. For this next one, it says consider the 7 graphs and functions that are increasing functions, decreasing, and constant. Sort the graphs into 2 groups based on the equations representing the functions and record them in the table. So what I'm going to have here is in group number 1, we have linear. All right, the linear forms a straight line, and that is graphs G, L, and O. Exponential are your curved graphs. So those are H, K, and P. What is the same about all of them? You have linear and you have curved. So we just sorted things into a function family. So we're going to group these into different function families. The first one is the family of linear functions. Linear functions form a straight line. Your basic generic form of a linear function is this: f of x equals mx plus b. That is very, very important to memorize. The family of exponential has an exponent in it. We have a times b to the x. So linear will form a straight line when we graph it. Exponential is going to be a curve because we have an exponent in it, b to the x power. So it says go back to your table and identify which group is linear. That's group 1. Which group is exponential? That is group 2. So if f of x equals mx plus b represents linear, describe the m and the b values that produce a constant function. Well, it's constant if the slope is 0 and b is a real number. That's the graphs that go across, just like this one does, where we had y equals 2, for example. So we just had a number, just a plain number. The absolute minimum and absolute maximum. All right, absolute minimum and absolute maximum. The absolute minimum is the lowest point on the graph. The absolute maximum is the highest point on the graph. So we end up with parabolas, curves like U shapes or V shape, or U shapes or like N type shapes with a curve on it. So an upside down U. So we have absolute minimums and absolute maximums. So an absolute minimum looks like this. Absolute maximum looks like this. So when we take a look at these, we have, this is an absolute minimum. It has a low point on the graph. This is an absolute maximum. It has a high point on the graph. So here's some more that we can graph using the calculator. So go back to your y equals. Let's clear out what's there. X squared plus 8x plus 12. So x squared. Now there is a squared button on the calculator right here, all right, next to the comma that says x squared. So we could use that for a squared. If we didn't want to use that as the squared button, we could do x caret button 2, and it works the same way. You just have to make sure that you tab off of it. And then plus 8x, plus 8x plus 12. When we go to, I put 22. When we put 12, go to graph. And when we graph it, this graph has an absolute minimum. This point right here at the bottom of our graph, that's the lowest that it goes. So that's the absolute minimum. So the next one says f of x equals the absolute value of x minus 3 minus 2. So that absolute value symbol, there is no button, no single button on the calculator to do the absolute value. What you have to do, if we go back to y equals and clear out our equation, what you have to do for the absolute value is see down here with the 0, you have the catalog feature. So we need to do second and catalog. When you do that, it puts all the different functions that are in the whole calculator in alphabetical order. For us, we're lucky, absolute value is first. So we're just going to hit enter because notice the arrow is next to the ABS. So that puts it in the absolute value symbols, all right? So now we got to type inside the absolute value symbol, we have x minus 3. To get out of the absolute value symbol, we need to tab over using the arrow pad and then minus 2. So then we hit graph. Notice that an absolute value is a V-shaped graph. Absolute value is a V-shaped graph. And it has an absolute minimum. This point right here is the lowest point on the graph. Go back to y equals, clear out that equation. Our next one is f of x equals x squared. So you type in x, and then we can just hit the squared button if you want, or you could do caret button and 2. When we go to graph it, this again has an absolute minimum. That is the lowest point on the graph right here. Go back to y equals, we'll type in the next one. The next one says the absolute value of x. So remember, absolute value, you have to hit second and then the 0 button, which is really the catalog. That will bring up the absolute value feature. And then we just have an x inside of there. So now we want to graph it. That again has an absolute minimum. That's the lowest point on the graph. Go back to y equals, clear out what's there. We want negative the absolute value of x. So hit the negative sign first, second and catalog, hit enter. We just have an x inside of there. We can tab out. So negative absolute value of x, hit graph. This one has an absolute maximum. All right, this is the highest point on the graph at the top of the upside down V. That's the absolute maximum. Go back to y equals, clear out what's there. Our next one says negative 3x squared plus 4. We can hit graph. This one has an absolute maximum as well. That is the highest point on the graph. Go back to y equals negative 1/2. So again, you could type in negative 1 divided by 2. You could do negative 0.5, or I like to use alpha and y equals and use number 1, the n over d. So do numerator over denominator. You have to use the arrow pad to navigate around the fraction. And then we have x squared plus 2x. Hit graph. Again, we have an absolute maximum because that is the highest point on the graph. Go back to y equals, clear out what's there. We have negative 2, and now we have second catalog, which is the absolute value. Inside that, we have an x plus 2. Tab out of the absolute value, and then we have a plus 4. Hit graph. So again, we have a V upside down V shape, and we have an absolute maximum value. So the next question says, consider the graphs of the functions that have an absolute minimum or maximum, sort them. All right, so if you wanted to see what they look like, these are what they look like. All right, our linear absolute value is a V-shaped graph, and the quadratics, the x squareds, are the U-shaped graphs. What is the same about all of them? They all have either a max or a min. So we really sorted things into 2 more function families. We have the quadratic functions. A quadratic function always has an x squared in it. It always has an x squared term. Linear absolute value, this is probably the easiest one to pick out because it always has those 2 straight up and down lines, which is the absolute value function, which is your linear absolute value function family. So these functions are part of the linear piecewise. You can't type these into the calculator. What I like to say, the linear piecewise function, these are the ones that have different parts and pieces. Notice that in this graph, it matches with graph A. It goes down and then across and then down. This one goes straight across and then up. This one goes up and sort of does a zigzag. So these are your parts and pieces. They don't just go up. They don't just go down. They're a combination of things. And notice when we graph them, they are different combinations of different parts and pieces. So from negative infinity to 3, we're going and doing this. From 3 to 7, we're doing this. From 7 to infinity, we're doing this. So we're doing different parts and pieces. These are very easy to pick out because they're all jumbled up and they're all like the zigzag type patterns where you're doing a combination of things. So Molly thinks these two graphs belong to the linear absolute value function family. Do you agree or disagree? So these would not belong because they are not functions. These fail the vertical line test. There are two dots directly above each other. So they are not part of the function families. And that's the end of the lesson.